Here's a quick one. This one doesn't even hardly count. It's so small. So 2-12. Let me show you over here. 2-12. Estimate critical pressure mixture of methane and N-hexane. I'll write that. Methane and N-hexane. If the critical temperature is known to be T crit equals 200 degrees F, compare with critical pressures of pure. So let's go after this problem. So this is what we're looking at. We want to find the critical pressure and we want to compare it. So if we look over here, this is telling me chart. So let's go back till we find the chart. Oops. It's somewhere in here. There we go. So here's our mixture of the critical loci. So the critical points right on these lines. You follow them? So we're looking at a mixture of methane and N-hexane. So here's the loci coming around like this. So we're looking at 200 degrees Fahrenheit. So if I come up 200 degrees, measure about right in there, and then over here, it looks to be about 25, 2750, 28, maybe 2800 and something. Let's say, I'll write it down. I'll say it's about 2850 psi. So now let's compare that to the values. These are values in the back of the book. So we'll look at back in the appendix. If I scroll down to the, almost there. If I scroll down to the appendix, here we go. So I can look, I can find my methane. Here's the critical pressure of methane. I'll write that. And methane is equal to 666.4 psi, and N-hexane is right here. Its pressure is 436.9 p crit of N-hexane. So let me pull this back so we can see that. So just so you can see what that looks like. So you can see this is the tricky part about mixtures, is your critical pressure can be tremendously higher than your critical pressures of the single components in this composition. So you got to go over and check that out on the plot showing the critical loci.